What is structural engineering, and what are the different types of structures, and how could they benefit us? Hi, my name is Amina Mumund, and I'm an engineering student hoping to get my master's in structural engineering from UTA. Deciding what to do before you enter college is key, but to do that you have to know a little bit about the subjects. This paper will talk about 3 different types of structures: shell structures, frame structures, and solid structures. I had a big problem starting college. I could not decide what I wanted to major in, and I was running out of time. I'm hoping that this article will break down an aspect of structural engineering to help those of you who are still trying to decide. The constructor lists many different types of shell structures for many different purposes. A shell structure is comprised of rounded pieces of material so that the arc has a significant role in the mechanical performance. Industrial structures such as a silo, is steel reinforced and therefore easier to develop and has been done many times before. However, in modern times, we find ourselves appreciating the texture, effectiveness, and strength of concrete. Aesthetically and architecturally unique constructions such as opera houses and museums all over the world are constructed via concrete reinforcement. Depending on the applied load, a specific batch of concrete is mixed for a specific area and takes a lot of time to cure, which can make the project more expensive due to the extensive use of labor. Not all structures are concrete reinforced. These structures are seen more commonly in modern life because they are cheaper and easier to produce. Hasib Jamal's article on frame structures says they are made to resist the lateral weight and gravity, complete with beam, column, and slab, to resist movement due to the applied load. Frame structures can be further divided into rigid frame structures and braced frame structures. Rigid frame structures are built to withstand deformation. This style of frame structure abstains movement from the applied load more efficiently than the other styles of frame structures. Pin-ended structures have pins in the ground surface for support. However, they can be considered non-rigid if the support requirements are removed. Fixed-ended structures have fixed supports that cannot be removed. Braced frame structures are usually used in between beams and columns to amplify resistance against the applied load in a diagonal fashion. These structures have proved more efficient than the latter in resisting earthquakes and windstorms. Gabled structures are commonly found in areas with a probability for heavy rain or snow. Portal frame structures frequently look similar to doors and are commonly used for industrial and commercial buildings. Not all structures are large, though. Some structures are small and are used to build other structures. Solid structures are being advanced by mechanical and materials engineers who are researching new types of materials and how they will stand against the test of time. Solid mechanics researchers are studying issues related to the construction and execution of materials for advanced thermostructural techniques. This research is extensive and centered in the mechanics of materials area and includes ongoing research to confront the issue associated with the use of advanced materials used in situations of a direct applied load. Solid mechanics is doubling in an alternative focus for advanced techniques for calculating innocuous lifetime limits in structural elements used in an expansive range of engineering methods. These techniques are vital for the innocuous design and function of the new engineering methods as well as a lifetime forecast of existing aging methods. The exploration includes modeling and experiments to advance a harsh understanding of microstructural, dimensional, and mechanical property variations experienced by materials used in adverse surface environments as well as complex fracture mechanics and statistical reliability calculation techniques. All of these structures are crucially important to engineering as a whole, and we thank our mechanical and material counterparts for helping to develop better systems and materials for the future. In conclusion, structural engineers are really important because they provide quality knowledge that no other engineer can. And there are 3 types of structures: shell, frame, and solid, all of which take great planning and expertise to design, execute, and maintain. If you have still not decided on a major, please consult your advisor. The time is now.